All right, I just wanted to take a little bit of time to look at a velocity time graph. At this point, we have talked about what velocity is. It is a vector. It's going to be calculated using the displacement of an object's motion divided by the time it takes to accomplish that displacement. And we spent a lot of time looking at a position time graph where the slope of that graph represented the velocity. But now we're looking at a velocity time graph where the velocity is actually represented on the y-axis. So sometimes it just takes a little bit of time for us to get comfortable with reading this particular type of graph. Number one, we've got to now pay attention to our labels and see that the slope is no longer going to represent our velocity. So make sure that we always read our labels and then think about what part of the graph do I need to look at in order to answer the question that I have been given. We don't ever want to do things out of habit. We want to make sure that we understand why I'm looking here. Why did I calculate it that way? How did I know that it was supposed to be this formula? Those kinds of questions are always going to be really important because the situations that we have throughout physics are going to change. And so we don't ever want to do things out of routine or out of habit. Our process absolutely can be a routine, but the actual execution should always be evaluated for that individual question. So now whenever we are being asked to determine the velocity for our object, we need to look at the label, find the word velocity on the y-axis, and look to see how that particular value is changing. So when we are being asked in this first question to determine the velocity for segment AB, that should be a really simple question. We are simply going to find segment AB and we're going to look to the y-axis and we're going to see that we have a velocity of 0 meters per second, simply because that is the value at that point. Then I'm asking you for the velocity for segment CD, and once again, this is a steady or constant velocity, so I look over to the y-axis because that's where my velocity is located on this particular graph, and so that is going to be 5 meters per second. Then it's asking me for my velocity for segment EF, and so once again, this is going to be located at the 0 mark for my y-axis. So I once again have a velocity of 0 meters per second. Now, sometimes students have created habits at this point about graphs, and they might say on a quiz or a test that all three of these have a velocity of 0. Remember, we are not evaluating the slope on this particular graph. We are simply reading the y value. So be careful in segment CD in the future. We want to make sure that we look to the y-axis to see that it actually has a value of 5 meters per second. Then it's asking us to describe the velocity for each segment. So now I'm going to be using words here in order to describe the velocity. I'm not going to give you a specific value because if you notice, some of these segments, the velocity changes. So I only asked you to tell me the velocity for the segments that had a steady velocity just to make it easier. So now we are going to use words to describe the velocity. For this first segment, segment AB, we could say that this particular segment has a constant velocity. That would absolutely be okay. But I want you to look more carefully. That velocity is at a value of 0. So if we are at a value of 0, I would prefer you to tell me that this object has a velocity of 0 or this object is at rest. All right, so for future questions, we want to make sure that we are focusing on the fact that my object is at rest for this segment. It is not wrong to say that it's a constant value, but you need to be specific. It's at a constant value of 0. If it's a multiple choice question, we were going to want to say that we are at rest at this particular segment. Then when we look at segment BC, they are now asking us to describe the velocity where we are starting at a value of 0, and we are ending at a value of 5. So the first thing I want you to recognize is that my velocity changed. How did my velocity change? It increased in value. I went from 0 meters per second up to 5 meters per second. So we are going to say that we have a velocity that increased. So we increased our velocity here. Now, a lot of students would probably tell me that the object sped up, and that is totally fine. Let's practice getting more comfortable with formal wording such as increased velocity or velocity increased. For segment CD, this is asking us to describe the velocity, so we're going to go to the y-axis because that's where the velocity is located, and it is at a value of 5 meters per second the whole time. So we could say that this is a constant velocity. And I want to point out to you that this is not an object that is at rest. This is a constant velocity of 5 meters per second. Okay, so again, we are evaluating the y value, not the slope, to describe velocity, so be careful with that. For segment DE, we have an object that starts at a velocity of 5 meters per second, and then it ends at a velocity of 0 meters per second. So this is an object whose velocity has decreased. This object decreased in velocity, or we could say that the object slowed down. Now, this one is tricky for students sometimes because they want to say something about it being negative. Again, we are evaluating the y-axis, not the slope. So I still have positive numbers. I am still moving in the positive direction. In fact, everything that we've done so far has been in the positive direction. I am simply slowing down at this point. So if I were in my car so far, I would have been sitting at rest. I step on the gas pedal as I'm driving forward. I maintain that speed for a moment, and then I take my foot off the gas and I step on the brake until I eventually come back to a stop. That's what we've done physically so far in our car, but we are in drive. We are moving forward or in the positive direction this whole time. So now when I get to segment EF, I am at a constant velocity of 0. So we would say that our object, is at rest here. Again, you could say a constant velocity, but we'd have to be specific of 0 meters per second here, okay? Now, when we look at segment FG, this one is the tricky part. For question number 3, it says, what is unique about FG? FG is different because we are now on the negative y side of our graph. We have to remember what that means. This is not a value of less than 0. You cannot go slower than 0 meters per second. What this means is that my object has gone from a velocity of 0 to a velocity of -5. So we have an object that has increased its velocity. An increase in velocity means that we sped up. This is something that speeds up, okay? Now, again, if I am in my car, what I have done is I have switched gears from drive to reverse. Everything on the graph before this moment, we were moving in the positive direction. We were forward. We were sitting. We sped up. We maintained our speed for a moment. We slowed down. We came to a stop. I'm now going to shift gears. I'm going to put it in reverse, and I'm going to press on the gas pedal so that the speedometer is going to increase in value. So my speedometer is going to go from 0 and increase to a value of 5 meters per second. However, I am going to be moving in the negative direction. So let's say that I put my car in reverse and stepped on the gas. Okay, so when we talk about rule number one, read your labels, it's super important that we form this as a habit because many students are going to struggle with giving the right answers as we get more comfortable with this graph because they have formed a habit of looking at the slope to give me the velocity. But since the velocity is now written on the y-axis, we have to simply read how is the value changing on that y-axis. The slope no longer tells me velocity. So just be very careful about that. And for a lot of students, it just takes a little bit of time to understand that we are increasing in speed because we have learned from math that negative numbers are less than zero. So we're just going to have to break that mentality. Again, I feel like if we relate this type of graph to being in our car, it's going to be a whole lot easier for us to process what's happening. Your speedometer of your car is going to give you the speed, the scalar version of how fast you are going. The negative on this graph, because it's technically a velocity, tells me that I'm moving in the negative direction.